Okay, yeah, that's totally fine. I would prefer if you did at least look through it to see if you knew the content. Now we'll be getting started in around 5 minutes. Oh, if you want a link to the handout, I can give it to you. Oh, by the way, the handout is on the Kid Teach Kid website under resources. The same link that was sent before. And it's under the AMC10 tab. So this link, I believe, and under the tab that says AMC10. Like, just heads up, 3 minutes is not enough to read that. Okay, everyone. So it's about 5 o'clock now, so I guess we'll start. Awesome. So okay, so first, really quick about the class. So this class in particular will be about geometry, but throughout these 4 days, we'll be discussing a bunch of topics across geometry, algebra, number theory, and combo. So about the format of the class itself, as some of you may have realized, there is a handout that's on the Kid Teach Kid website that I would like for you to read before class. We're going to be doing some notes in class, and these will be shared as well. And there's also a homework, which is basically just a graded problem set. And I'd appreciate it if you submitted it before like today night. So first, we'll be going over a little bit of theory, and then we'll dive deep into problems. So, okay. So the major topic for today will be coordinate geometry. So coordinate geometry should never really be your first way of approaching a problem. Like coordinate geometry, if you think about it, it's really more like a backup. Like it'll almost always work, and it can help. And if you can do it quick enough, you can really get a bunch more of those really harder end geometry problems. So let's start with the most, let's start easy and get a little bit harder. So first thing we'll be discussing is the distance. Oh, by the way, feel free to use a question and answer at the bottom of your screen to send questions. And I would very much encourage you all to send questions. So the distance formula is usually if we have 2 points, x1, y1, and x2, y2, then the distance between these 2 points is equal to x1 minus x2 squared plus y1 minus y2 squared. Okay. So basically, this is just an application of Pythagorean theorem, or just basic Python. If we have 2 points, we can find the x distance between them. It's just the absolute value of the difference of their x coordinates. Because of course, yeah, that's just going to be x1 minus x2. And the y distance between them will just be the absolute value of the distance between their y coordinates. Like if you don't understand anything I'm saying, or if you want me to go faster or slower, please say so with the question and answer thing or the chat. So basically, by Pythagorean theorem, all you have to do is just square these and add them together, and we'll have the square of this part of the triangle, which, because this is a coordinate plane, these will be perpendicular to each other because they're parallel to the axes, and this is the distance between this point and that point. So basically, we know that the square of an absolute value, when you square an absolute value, the actual absolute value symbol will disappear for reasons that we'll talk about tomorrow. But basically, once we do this and we square root it, we'll find this. So basically, you can think of this as one of the most fundamental ideas behind coordinate geometry, because like, what's the point of abstracting something out into coordinates if we can't really get anything from them? So basically, taking this into account, we can do a few more things, which by themselves are exceptionally interesting. Something else we can do with any set of 2 points, apart from taking the distance between them, is averaging points. Okay, so basically, the most common example of this is the midpoint. So, of course, midpoint is just the point in the middle between 2 other points. So let's find the midpoint of point A and point B, where A has coordinates x1, y1, and B has coordinates x2, y2. So on a coordinate plane again, say this is A and this is B. Well, okay, so what do you know about the midpoint? Well, simply put, it's the point in the middle between all of these. So if it's in the middle, it'll of course have we can just look at its y value and x value separately. So because it's in the middle of A and B, its x coordinate will also be the middle of A and B's x coordinate, and same for the y. So basically, you can just describe that the midpoint of A and B is just going to be x1, x1 plus x2 over 2, and y1 plus y2 over 2. So, oh, by the way, if you guys have any questions, like, please ask in this question and answer thing. Like, that helps us a lot. Awesome. So, okay, great. That's the midpoint. So, like, how do we find some other type of point? Let's say instead of let's say we didn't want the point exactly in the middle of point A and point B. Let's say you wanted the point that was, say, really close to A and not so close to B. So basically, let's call this point K. Let's say we want the ratio of AK to KB to be, say, 1 to 2. Well, here's where we can think about things a little bit differently. If we're saying K is on the line between A and B, and it's 1 to 2, like if you guys know mass points, it's basically the exact same way to do it. But basically, because this is a lot closer to A, it's a lot more like A, right? And because it's a little bit further from B, you can think of it as it's a lot less like B. So basically, the distances, this is just 1 and this is 2. Because this is 2 times closer to A, we can say K is 2 times more like A than B. Or basically, K is basically around, you can call it similar to 2/3 of A and 1/3 of B. Now, this idea may seem a little bit abstract, but oh yeah, okay, that's fine. Yeah, it's totally fine if you're just going to be in 6th grade. If you would want me to go slower, I'm totally fine with that. Okay. Yeah, we will be going from the basics of coordinate geometry. Okay. So we can just call this point K is equal to 2/3 of point A plus 1/3 of point B. That's basically what we've been saying. So this notation is a little bit strange, but all this really means is that the coordinate of point K is just going to be whatever the coordinates of point A were, or x1. Well, let's just look at x coordinates first. It's just going to be 2/3 x1, because that was the x coordinate of A, plus 1/3 x2, the x coordinate of B, and the same thing with y coordinates. 2y1 over 3 plus 1/3. Prefer going faster? Okay, that's fine. Yeah, I know this may be a little bit basic to a lot of the people who have done a little bit more contest math. Okay, awesome. So a nice application of this in 2 dimensions is the centroid of a triangle. It's basically just the center of mass of a triangle. And we can get that by, because it's the center of mass, just averaging all these 3 points. Or let's say this was 0, 0, 2, 1, and 1, 2. Then we can say the centroid is located at the point 0 plus 2 plus 1 over 3, 0 plus 1 plus 2 over 3. If you're not convinced, well, we know centroid divides a median into a 2-to-1 ratio yet again. And of course, that's median. Then this is just 1 and 1. So basically, we can call this point as half, label triangle. Half A plus C. And then we want this 2 times because 2 here and 1 here. So basically, it's going to be 1/3 B plus 2/3 of 1/2 A plus C, which is just 1/3 A plus B plus C, or what we have here. So this will allow us to see that the midpoint of this triangle is just, the centroid of this triangle is just 1, 1. Awesome. So we will be doing, okay, so a few more important things you have to know. I'll try and go quickly. Just with slopes, lines, really important. So the formula for slope, rather obviously, the formula for slope, which is usually denoted by m, will be, we just take 2 points on a line. It's the difference in y over the difference in x. Okay, so basically, it's just the change in y over the change in x, or as a lot of people like to call it, and me too, the rise over the run. Or from this point to this point, this line rises some value delta y, and this runs, or it goes, some value delta x. So it's just delta y over delta x. So definition of slope. So something else which is really important to know, we have perpendicular lines. Okay, imagine those are right angles. Then this slope, m, well, we can easily tell the slope of the other line, which will be negative 1 over m. So that only applies to perpendicular lines. Awesome. So, okay, so from something else, sorry, one last thing, which will be a little bit more relevant later. If this line makes an angle theta with the x-axis, then the slope of this line is equal to tangent of theta. Oh, by the way, can you all please respond? Are you all at least somewhat familiar with trigonometry? Yes. Yes, awesome. Okay, yes and no. Okay, that's fine. So we will cover basically what this means a little bit later, and we'll have some applications of that too. Okay, so lines are basically just slopes, or they're just, well, you know, straight lines. So they have a slope and a y-intercept. That's usually the most common way to find out what lines are. So in fact, the most common way, we know the slope m, we know the y-intercept, which we'll call b, and we can just easily say y equals mx plus b. And basically, if we plug in a point x, we'll get its y value on the line. Awesome. Very basics, it's not bad either. We'll be teaching that in this lesson. So this is the most basic formula of a line. This is its slope, and this is the y-intercept. Some other ones that you should definitely know are y, this one. Basically, we know this is a point on the line, and then these are just arbitrary coordinates, which will be on the line too. So, and this is the slope of the line. So this works because y minus y naught over, because y minus y naught over x minus x naught is equal to n. So basically, this just fixes a point on the line, and then because the slope of a line is always constant, we can easily find a relation between the y and x values of any point in the line. So the last method for a line is a little bit less common, but it's called standard form. So it's ax plus by plus c equals 0. So the only really problem, well, not really, with this form is that it's really not used that much in quantist math, because it's so much easier to work with equations with like y equals mx plus b, or even, and it's really easy to find lines given a slope and a point with the y minus y naught equals m x minus x naught formula. But this line, there's a really nice formula that goes along with it called point to line. So basically what this means is that if we have some point, so let's say that line, we could just graph as this, and we had some point on the coordinate plane, and we want to find the distance from this point to this line, basically like the closest distance we can get, which obviously will be ridiculous. There's a really nice formula we can have for this. So if the point here was x1, y1, sorry. Then basically the result we get from plugging it into here, or ax1 plus by1 plus c, if we take the absolute value of that and divide by the square root of a squared plus b squared, you can think of this term as a little bit like the Pythagorean theorem, but just with this a and this b. It's basically like this amount, but because we're doing perpendicular, it's going to be like that. So this is the celebrated point to line formula, and it allows us just for any x1, y1 to, we can just plug it into here and find the distance from any point to a line. And this is like, believe me in saying that this is really useful and can save a lot of time. So something else, 3D geometry is becoming a lot more popular on the AMCs. So it's important to know like that, yes, you can most certainly use coordinate geometry. Oh, gosh, that's a horrible cue. You can definitely use coordinate geometry on 3D. So, but the only thing is that points, of course, just for like x, y, z coordinate. We know how, and then if you just think about it, a plane, it's like that standard form. So basically, this is just an equation for a plane. So we can obviously we can technically generalize it to more dimensions, but after that, it becomes really hard to visualize. So yeah, this is just a nice formula for a plane, and it's a really good idea of how standard form works. Something else, point to a plane formula, it's exactly the same as point to line. We just plug in the point into this, and then we divide by a squared b squared plus c squared. Okay, if you have any, I know I went a little bit fast, so if you have any questions, please do ask. Yeah. Okay, awesome. So now that we're done with points and lines, we can go to another basic thing, circles. Or well, another fundamental, circles. Circle. So we can, the most popular way by far to characterize a circle is by its center, which we'll just call A, B for now. Its center will obviously be a point, and the radius of the circle, or the distance from the center to any point on the circle, which we'll call R. Then we can just describe, let's say xy was a point on the circle. Then we can say that x minus a squared plus y minus b squared is equal to r squared. Basically, this is just Pythagorean theorem and distance formula all over again. If we square root it, we'll see basically the exact same thing as distance formula, where the distance from a point on the circle to the center is equal to r. Something else that is actually coming up a little bit more on AMCs, let me draw this, are ellipses. So ellipses can definitely throw people off because they seem a little bit complicated at first. Like, I don't know any formulas for this, how am I going to deal with it? But a really good way to think of ellipses are just stretched circles. So let's say this ellipse was, okay, let's say it went this way 9 and down 4. Well, we can just easily turn an ellipse into a circle by just shrinking it this way with a transformation. We should probably shrink the entire plane. So basically we can just write this as a circle, x minus a, x minus, center at the origin, x squared plus y squared equals 4 squared or 16. And then we just dilated the x, or we just compressed it a little by a factor of 4 over 9. So basically, once we're done and we computed the answer, we just need to multiply back by this, or however else we're supposed to find it. Okay, awesome. So now the last thing that is coming up a little bit more on AMCs are parabolas. So parabolas, there are a lot of good ways to write it. One is y equals ax squared plus bx plus c. this way, it's really easy to find the roots or the places where this is 0 because we all know the quadratic formula. Another way to better visualize it graphically, the parabola is y is equal to 1/4p minus h squared plus k. This is vertex form of the parabola. So if we just draw a parabola, so this point, its lowest point, hk, is the vertex. Because, well, there's only one of them. For every other point, there are two possible y values. For every other y value, there are either 0 or two possible x values for which that y value is replaced. But there's only one of them for the vertex. Because this vertex is like the lowest possible you can get on a parabola, it's a really good thing to consider if we want to optimize the parabola for saying, hey, this is the lowest point or this is the highest point. And that we'll be talking about a little bit more tomorrow. So some of you may have noticed, usually a lot of people write it as a x minus h squared plus k. But the reason I wrote it as 1 minus 4p is that this p is a really special number. In fact, there are two not so commonly talked about things in a parabola called the focus and the directrix. They hardly ever show up on AMC contests, but I have seen them show up on mock AMCs in the past. So basically, the focus is just P, the point P above the vertex. The directrix is the line P below the vertex. And basically, a really good, cool property of the parabola is that you draw a focus, you draw a line from the focus to any point on the parabola, then you drop a perpendicular from this point to the line, to the directrix, and you know these lengths will always be equal. And really cool application of that is that in a semicircle, if we have a inscribed circle, well, obviously there are infinitely many of these. If we just consider tangent to two parts of it, if we look at the shape that contains all their possible centers, it will be a parabola with directrix, this line, which is supposed to be tangent to the top of the semicircle, and focus at the center of the semicircle. So yeah, this concept has actually come up quite a good bit in mock AMCs these days. Okay, so the very last thing that we're going to be doing is finding areas on the coordinate plane. There are two main ways to do it: Shoelace formula and Hicks theorem. So the most common one is definitely shoelace, because that means if you're given any 3 points, we can find the area of a triangle. Or really, if we're given any set of points, we can find the area of the polygon inscribed in that. Determined by those. But Hicks theorem is a little bit more complicated. Basically, if we know the number of, okay, so we'll start with Hicks. Basically, if we know the number of points so if the shape has all of its vertices on lattice points, and we know the number of lattice points inside this shape, this triangle, then we can write that the area of the triangle is equal to number of points inside the triangle plus half the number of points on the border minus 1. So let's say there were some, okay, let's do a little example. So let's say this is a point 2, 0, 0, 0, and 0, 2. Rather, obviously, the area of this is 2 times 2 over 2, which is 2. Let's see what Hicks theorem says. Okay, so how many points are on the border? There is 1, 2, 3, 4, 5. This would be obviously a lot easier with a coordinate plane. But there'll be one more, yeah. Oh, oops, sorry. This is supposed to be there. So there are 6 points on the border. There are no points inside. By points, I mean lattice points, because like, yeah, there's nothing inside. 6 points on the border, -1, and this simplifies to 3 minus 1, which is just 2. So then, what I would consider a better way to find something is with Shoelace formula. So, yes, both Shoelace and Pix work for all polygons, as long as they are actually polygons and they don't intersect each other. So basically, let's say you wanted to find the area of this shape. Yep, Shoelace would work here. But if you wanted to find the area of this shape, Shoelace wouldn't work. But Pix still would. Basically, the reason for this is because this shape is convex and this shape is concave. Or basically, you can think of that like, well, this shape is basically cheating. It goes into itself, not outside. So yeah, for any shape that is actually convex, Shoelace will work. And for basically any other shape, any shape total, Pix will work. So, okay. So Shoelace formula. So let's say we want to find the area of a triangle with points 2, 4, 3, 7, and like 5, 8. So pretty thin triangle. What Shoelace says we should do is first step, write out these points. And then at the end of this, just rewrite the first point. If you are doing this for just any polygon, then you need to write this out in clockwise or counterclockwise order, or else it won't work. Then step 2, let's make X's here. So this is where you get the shoelace thing, because this looks a little bit like the laces on your shoe. So then we just need to multiply the numbers at each end of these lines. So here, 4 times 3 is 12. 7 times 5 is 35. 8 times 2 is 16. 2 times 7 is 14. 3 times 8 is 24. And 5 times 4 is 20. Then step 3, we add up all these numbers on all the sides. So this is 63, and this is 58. Yeah, I can do that. Awesome. And then we just subtract these numbers, and take their absolute value. So 63 minus 58 is 5, simply. Then Shoelace just states that the area of the triangle is just going to be this 5 over 2. Or basically just the difference of these two values divided by 2. Okay. Okay, so Shoelace does also work for decimals, but Pix does not. So the theory behind this is a little bit complicated. It has to do with like vectors and cross products. So you can look into those later, because okay, a little bit. You don't need to know this for AMC10. Basically, Shoelace is just saying, okay. So basically, what Shoelace does, it's just we need to take the cross product of two vectors and like the determinant of like the okay. So basically, if we have two vectors, their cross product will give the area of the triangle that they form. And from that, we can do some nice manipulations to find that basically the exact same thing we found can be done with a matrix and finding its determinant. But you definitely don't need to know that for either AMC12 or AMC10. That's still a good question. Okay. Yeah, don't worry about it. Okay, so that was a whole ton of theory. So please, if you all have questions, please ask. And something else, if you have questions to ask, please use the question answer thing at the bottom of your page. It's a lot more organized than the chat. Okay, no questions? Awesome. So we'll go into problems now. So, okay, first problem is 2016. 2016 AMC 10B number 19. Awesome. So basically, we have a nice figure here, and we're given some lengths. Sorry. Sorry, give me some time to draw this. Okay, so we're given this pretty confusing figure, and we're asked to some points. And we're asked to find the ratio of PQ to EF. So the intended solution for this is to use similar triangles. So basically you extend this line here, and you have a ton of similar triangles to work with. But like it's pretty likely that you don't notice that in the actual competition. And something else, I believe that coordinate geometry is still a little bit faster actually. So for that reason, it would be a little bit better, in my opinion, to use coordinate geometry. So just let's set. So obviously this is not a coordinate plane. Like where are the coordinates going to be here? Well, let's make some really convenient axes and an origin. So let's say the axes, the y-axis will be AD and the x-axis will be DC. So we can just call D the point, our origin, 0, 0. So for further information about choosing an origin, that is in the handout I posted. So, okay, great. We have D as our origin. So now we need to find equations of lines. How are we going to do that? Well, first of all, what lines do we really need? Well, and what's our goal here? So basically, we know the length EF. That's pretty easy to calculate. But we need to find the length PQ, and that's a whole lot harder to find. However, if we just find the coordinate of point P and the coordinate of point Q, then easily we can find the distance PQ by distance formula. So how are we going to find P and Q? Well, first, we can notice that P is the intersection of line AC and line EF, and Q is the intersection of line AG and EF. So basically, if we find the equation for each of these lines, we can find the points P and Q, and then we can find the distance PQ and then the distance EF, and then divide them to get our answer. Okay, so I'll give you guys a little chance to work on this, but like let's just go one step at a time. So this distance AD is just 3 plus 1 or 4. So we know that the we know that the y-intercept of this line AC is going to be the point A, or basically 4. So we know that the line AC can be expressed as mx plus 4. But the real question here is, how are we going to find that m? Well, pretty simply, we want to find AC, right? So we run the distance AB, and then we drop the distance BC. Or basically, our m will be the distance AB, which is 5, as our denominator. That's what we run. And then we rise -4 because we're dropping 4. So from that, we can find the equation of line AC as y equals -4/5 x plus 4. Awesome. So now I'll give you probably a minute. So could you guys try and find the equation of line AG? Line AG. If you have the answer, please just private message to me in the chat, please. Also, if you have any questions, please please ask. I know I've been going a little bit quicker than I intended. Okay, nice try about that. Oh, yeah, actually, yeah, that's right. That's right. Nice. Yeah, that's also right. Nice. Yeah, good job, Justin. Good job, Joshua. Those were both right. Would anyone else like to try? Don't worry, it's totally fine even if you get a wrong answer. Okay, awesome. Good job, everyone. You all did it perfectly, or at least those who submitted. So yeah, the equation of line AG is y. Oh, where do you start learning these things? Well, some good websites for learning topics are AOPS, or the art of problem solving. For more basic topics, the brilliant.org website is fine. And then for like really basic topics, Khan Academy is also great. But like once you've learned like the very basics, like AOPS is like the best by far. Yeah, don't feel bad if you don't learn this, because I think you're supposed to learn some of this when you take geometry, which is like technically a 10th grade class. Yeah, brilliant.org is quite nice. Okay. So that was the equation of line AC. Then y equals -3/5 plus 4 as the equation of line AG. So now all we need to do is find the equation of line EF, and then yeah, AOPS is the rest by far. So all we have left to do is find the equation of line EF and then intersect these, and we'll be done soon. So for EF, the equation of that will just be y is equal to 2x minus 4. Awesome. So now we want to find the point P. The point P is the intersection of line AC and EF, or the intersection of these two lines. So we all know how to solve this system of equations. So if we solve it, we find 2x minus 4 equals -4/5 x plus 4, because the y values are equal. It's just 1 point. And we find that the x value is 20/7. Awesome. So now we need to find the point Q, or the intersection of line AG, the intersection of this line, and the intersection of EF, this line. So could someone tell me oh, sorry. Good find. Could someone tell me the intersection of, the x coordinate of the intersection of these two lines? Or basically what you get from solving this. Yeah, that's right. Good job. By the way, please attempt to private message next time, so everyone else has a chance to do it. Yeah, so 40/13 is correct. You just solve this, and that's what we get. Awesome. So now we know, okay, let's go back to our diagram. Okay, now we know the x coordinates of both P and Q. So all we need to do now is find the ratio of PQ. So from x coordinates, we can find y coordinates, then the distance PQ, and then the distance EF. Well, awesome, but that sounds like a ton of work to do, right? Well, it's a good thing that we're all lazy mathematicians who want to find really nice ways, nice clean ways to do things. So, well, it's a line, right? And we know the things about the slope of a line. It's like if a line goes like x this way, then no matter what, it'll always go some constant distance d that way. Like no matter if this x is at any point in the line. So basically, if we want ratios of this to the whole thing, all we need to do is find the ratio of this distance to this whole distance here. So that is a whole lot more manageable because we have these x coordinates. So all we have to do now is subtract these x coordinates. So we find this x distance, then we can find this entire EF distance and then divide. And if we do that, I'm quite confident you all can do that. We'll get 10/91. So you can check your work later. Nice. Okay, so does anyone have any questions about that problem? Is there any section you would like me to explain, please? Okay, awesome. So next we'll try a little bit harder problem, which is the 2013 AMC10 number 4. So a nice rule of thumb on AMCs is that like the last like 5 or so problems on the AMC are supposedly close to like the level of the first 5 problems on the AME. Oh, slow down? Okay. Would you like me to go over the past problem? Like again? Okay. Okay. Yeah, sorry. I'll slow down a little. Okay. So basically a nice rule of thumb is that the last 5 problems on the AME, the first 5 problems on the AME are about equal to like the last 5 problems on the AMC. So you should also try practicing with a few AME problems so you could get a better grasp for AMC. Anyway, okay, let's look at this problem. What it says, we have a Cartesian plane, which is just your normal coordinate plane. Then we're given 2 points. We have point A, which is 1, 0. Oh yes, the AME is basically like the level above the AMC. But still, like the first few problems in the AME are actually a little bit easier than like the harder end of the AMC. So basically, like if you do really well on the AMC, you'll qualify for the AME. So you got to take that test. And the point of AME is so you can qualify to take another test. So you can qualify to take another test. So you can go to a place and take another test and then take another test. Great, isn't math fun? Okay. And we're given the second point, A is 2 root 3. Sorry. So then these guys basically say we have an equilateral. This is actually a little part of an equilateral triangle. And its last vertex, C, is in the first quadrant. Well, technically you're always learning just for the sake of learning, but like this is directed a little bit more to the competition. That's why it's called the AMC10 class. AMC10 is the name of the competition. Okay, so we know C is in the first quadrant. And then they're asking you for what is this? Okay, so then they say we're given some point P is the centroid of ABC. And you want to find, okay, this coordinates is x, y. So what's the product x times y? There is no AMC11. There's AMC10 and AMC12. So AMC10 technically covers 10th grade topics and below, but AMC12 technically covers 12th grade topics and below. However, this designation is sort of bad because like it goes like way above the level of these things. But just technically saying, in 10th grade they teach geometry. The MAE people who make the tests think they have the right to do however hard geometry problems they want. But basically, if you know all the school stuff, you'll be able to understand this. Oh, the coordinates for the last question? Yeah, of course. Yeah, sorry for not responding earlier. So in the last question, we knew that the reason that we found out the lines is because we knew that this point P is the intersection of the lines EF and AC. So basically, we knew that the line AC is y equals -4/5 x plus 4. And the line EF is 2x minus 4. And the point of this is so that we can find out, okay, I want to find, there's only one point where it intersects. So I want to find the pair xy that solves this system. So now we can just treat it like a little bit of algebra. The y's are equal, so you can set these parts equal to each other. So 2x minus 4 is equal to -4/5 x plus 4. Or basically we got 14x over 5 is equal to 8. And this gives us this gives us x is equal to 40 over 14, which is 20 over 7. Okay. Oh yeah, sorry about that. So once you do have the points, you could do distance formula to solve. That's probably the most easy way to think about it. But I don't like distance formula because it's really bashy. So what I did is we have this entire distance. This distance, just think about this triangle here, right? So basically the ratio, we only want the ratio, right? We don't actually want the distance. So you want to find the ratio of PQ to all of EF. And basically, if we drop the perpendiculars from P and Q to this line, FC, then we can just say that the ratio of this to this is the ratio of of PQ to EF. And because it's a lot, so we just found out the x coordinates. So if you wanted to find actual coordinates of P and Q and then the distance, we'd have to solve to find the y coordinates and then, oh my, so much more. But now we can just do this and it comes a little bit easier. Anyway, back to the Amy problem you're working on. Yeah. For your question, Amy, I am actually not sure. But just Google it. I'm pretty sure the AOPS forums there are some answers to that. Okay. So let's go back to the Amy problem. So we're given point A is here, 0, point A is 1, 0, yes. And point B is 2, 2√3. So we need to find our third point C, which will probably be somewhere there. So actually we can skip a little bit of it, because we know that because it's an equilateral triangle, and so we know this is a ratio of 2 to 3. Sorry. We know that this to that, we know that this to this is a ratio of 2 to 1. Or basically, because we know the side length already, the length we can easily find as, well, okay, I'm getting a little ahead of myself. We want to find this midpoint of AB. So we know how to find midpoint. We just average the points. And we get 3/2 and √3. So then, so because the slope of AB is 2/3, we know how to find that. We know the slope of this MC, which is also the slope of MP, is going to be -1 over 2√3 by the formula we discussed earlier. So also, because this is an equilateral triangle, so first we can find the distance from A to B. This is not so bad. It's 1 and 2√3, which not so conveniently works out to √13. So because this is √13, this will be √13 over 2. 30, 60, 90, this is √39 over 2. And because it divides it up into this ratio, 1 to 2, we can find that this length will be 1/3 of the whole length, or √39 over 6 is length NP. So now we know the slope here, and we know this distance. So what we can do to solve is we can say, okay, let's say it moves A down and B to the right. Well, we have Pythagorean theorem. And we know the slope, which is basically the ratio between these two things, where we know that negative is our slope, which we determined to be -1 over 2√3. So then this is a system of equations, and we can easily solve them for A and B. Then once we know A and B, all we have to do is just add, we'll just go down A from M and then go right B, and we'll find the coordinates of P, which come out to be 5 over 2 and 5 over 2√3. So where √3 in the denominator. So then we can multiply them together to get 25 √3 over 12, which is the answer. I encourage you to do this actual adding process together, just for practice. But we have less than 10 minutes left. I did not talk about trig today. Okay. I'll have to speak for this. So basically, in a triangle, let's say we have some angle here, theta. Then, so let's define some terms. So the hypotenuse, you know, from Pythag is just the longest length of the triangle. We'll call that h. So you see how there are two sides which touch this angle here? Well, this angle is opposite of this side, because it doesn't really touch it at all. Because it's opposite of that, we'll call this the opposite side. And because this side is not the hypotenuse and it touches this angle, we'll just call it the adjacent. And adjacent means it's just a fancy word for touching. So this, we'll call it A. So then there's the famous mnemonic SOHCAHTOA. Basically, some nice functions of this angle. The sine of this angle is just defined as this O over this H. The cosine of this angle is just defined as the A over the H. And the tangent of this angle is just defined as the O over the A. So the cool property and the reason that we have this is that no matter what triangle you're at, if this is a right angle, then the ratio of this O to the H will always be the same because of similar triangles. So yeah. But there are a few really cool things we can do with sine and cosine that actually makes it, you know, more than just applying in right triangles. The first thing is the law of sines. Let's say this has angles A, B, C, and sides a, little b, little c. The law of sines, or LOS, states that a over sine a is equal to b over sine b plus c over sine c. Sorry, equals c over sine c. So basically, if you were to visualize it, it's basically like saying if this length was x, so we know this angle A here, its opposite would be x. Its hypotenuse would be c because this is a right angle. So basically, you can just say sine A is just x over c. So believe it or not, if we plug it into this angle, sorry, this formula, we can find AC over x is equal to these other things as well. So something else, there's also the law of cosines. You see the last thing use sines, this one uses cosines. In a triangle, if we're given two lengths and the angle between them, then we can find this length as a little bit like our Pythagorean theorem, but then we just need to change a little bit. So it's root a squared plus b squared, but then minus 2ab cosine of theta, the angle between them. So basically, Pythagorean theorem is just a special case of this because we can find out that cosine of theta is just equal to 90. Sorry, cosine of theta, sorry, cosine of 90 is just equal to 0. And with a right angle, that would be a right. With a right triangle, that would be a right angle. Okay. So I would have liked to go over something else, but I think just some nice other formulas you should know. Sine of x squared plus cosine of x squared is equal to 1 for any value x. Yeah. So basically, using this, you can transition between sines and cosines and solve problems really nicely. So on the handout, there are a few sine and cosine formula explanations. Oh yeah, sorry, one last thing. Okay, I'll cover that a little bit later. On the handout, there are some nice problems solved with these properties. So yeah. Okay. Yes, we do have a little bit of time at the end, so I will go to rectangle 1 and say how we got the ratio. Oh wait, by the way, person who asked that question, by similarity ratio, do you mean like the ratio after we found out what the points were, or just like before? Oh, okay. So do you know what similar triangles are? Yes. Oh, okay, sure. So it's like saying, so here was our diagram. Here's our diagram. We'll just take out this section. Here. So this would be our point E, F. And this is P, and this is Q. So let's just drop some right angles here. So let's call this P prime, Q prime, and F prime. So we know that because these triangles, this angle is shared between EPP prime and EQQ prime. And we know that EPP prime and EQQ prime are similar. So basically, because we know this, we can say that EP prime over EP is equal to Q prime over Q. Basically, using a nice little math trick. This is also, because these ratios are the same, we can just subtract across them. So EQ prime minus EP prime over EQ. So that's equal to this, which is just P prime Q prime over PQ. And basically we can extend this. Like if we do this again for this EQ Q prime and EF F prime, then we can basically find that P prime Q prime over PQ is EF prime over EF. Or basically P prime Q prime, which is this length over this entire length, is equal to this little length over this entire length. And because this little length over the entire length is what we wanted, we can just say it's also equal to this length over this entire length. And because we already knew this length, it's a lot easier to find out. Okay. So it seems like it's 6 o'clock. Please, everyone, please actually do the homework questions and please also do the handout questions. Yeah, so, but now I'll be turning it over to Harvey and Aiden as they talk about debate, I believe.